Today we're going to learn lesson 7.4 about quadrilaterals. A quadrilateral is a figure with 4 sides. When naming quadrilaterals, use the name that is most specific, because we're going to notice that a lot of these will overlap. Okay, so our top category up here is a quadrilateral, and anything underneath it is considered a quadrilateral. So all of these are considered quadrilaterals. All right, there are 3 different types of quadrilaterals that we are going to learn about today. Okay, we're going to learn about a trapezoid. A trapezoid is a quadrilateral with exactly 1 pair of parallel sides. We show parallel sides with these little arrows. Okay, so that shows that this side is parallel to this side. Okay, a parallelogram is a quadrilateral with opposite sides that are parallel and congruent. Notice that this side is parallel to this side. This side is parallel to the opposite side over here. Opposite sides are also congruent. So this shows that the top and bottom are congruent. And this little hash mark over here and over here show that the sides are congruent, meaning that they're the same length. All right, there's many different types of parallelograms, so we're going to go into those next after we talk about our kite. So a kite is a quadrilateral with 2 pairs of congruent adjacent. Remember that adjacent means next to. So 2 pairs of congruent adjacent sides and opposite sides that are not congruent. If you need to bring this to the side because you're not going to remember what op means, you can do that just like I did. So our kite has 2 pairs of adjacent sides that are congruent. So notice how this side over here is congruent to the side that's next to it. Okay. And over here we have this side, which is congruent to its adjacent side over here. It's next to it. Notice how this side is not congruent with this side. Opposite sides are not congruent. All right, let's move into the 3 types of parallelograms. Our first is going to be a rectangle. We've all learned about rectangles before. A rectangle is a parallelogram with 4 right angles. Okay, so all of these corners are going to be right angles. We're also going to notice, if I were to erase this, because now I'm covering up those hash marks, that opposite sides are congruent. Okay, and this is what makes it different from a square, because a square is a parallelogram with 4 right angles also, but it has 4 congruent sides, so all the sides are the same length. Okay. A square is also a rectangle. Okay, so remember back up at the top when I said when naming quadrilaterals, use the name that is most specific. You would not name a square a rectangle or a parallelogram because square is the most specific category that it would be. All right. Parallelogram can also be a rhombus. A rhombus is a parallelogram with 4 congruent sides. Okay, so this side is the same length as this side, which is the same length as this side, which is the same length as this side. Let's notice that these angles over here are not right angles. Okay, so that's what makes it different from a square. Knowing that a square is also a rhombus. Right, but using those most specific names. So let's do some practice. Feel free to pause the video and do these examples on your own, and then check your answers once you're finished. If you're not sure how to go, then you can just follow along with the video. So number 1, we have a quadrilateral that has 4 congruent sides, but we don't know what the angles are. If we look back at our notes, 4 congruent sides, no. Here we have 4 congruent sides, but those are right angles. 4 congruent sides, right angles. So here we have our rhombus, which has 4 congruent sides. So this would be a rhombus. Number 2, we have a shape that has 2 parallel sides. That's what those little arrows mean. Parallel sides and 2 congruent sides. Okay, well these are all 4 congruent sides or 4 right angles, so we know it's not going to be a parallelogram. A trapezoid has a quadrilateral with 1 pair of parallel sides, and a kite doesn't have any parallel sides. So we know that this is then going to be a trapezoid. Right. Last but not least, we have a shape here where the top is congruent to the bottom and one side is congruent to the other side. All angles in the corner are 90 degrees. This one should be pretty easy to name. This would be a rectangle. We've seen these before. All right. Before we move on, if you would like to go back and rewind to review that information, because we are going to be moving on to some new stuff now. All right, so just like with those triangles, we're going to talk about how many degrees are inside quadrilaterals. Okay, since we already know that triangles have 180 degrees inside them, let's see how many triangles we can form from connecting the corners of a quadrilateral. Okay, so if I were to connect that corner, how many triangles does that form? Well, we see 1, 2. What about the second one if we connect corners? 1, 2. And with our rectangle, if we connect corners, we again have 2 triangles. In each of these triangles, we know that there's 180 degrees. Okay? This is not a coincidence, because the sum of angle measures in a quadrilateral is going to be 360 degrees, since each quadrilateral is composed or made of 2 triangles. All right, our last thing we're going to do today is just solve some examples using an equation to find that missing angle, just like we did with triangles. So number 1, we know that the measure of quadrilaterals add up to be 360, as shown above, and proven by our triangles that we drew above. All right, so I'm going to take one angle, which is 115, plus another angle, 70, plus our third angle, plus our missing angle, and that's going to equal 360. All right, first thing we have to do is combine some like terms, so we have these numbers here that we can combine. When I add 70 plus 75 plus 115, I should get 260 plus x equals 360. Our last step to solve is to subtract 260 from both sides of that equal sign. Remember, whatever we do to one side, we have to do to the other in order to make it, keep it an equal equation. We take 360 minus 260 and we get 100 degrees. Do not forget your label of that degree sign. At this time, if you have any questions on this example, please make sure that you write it over here so that you can remember to ask me in class. All right, example number 2. Again, we know that these angles inside a quadrilateral add to equal 360. So our equation is going to be 100 plus 80 plus 100 plus x, and I got those numbers just from the angles that are given, and then our missing one, which equals 360. I'm going to again combine those like terms. 100 plus 80 is 180, excuse me, plus one more 100 is 280, plus x equals 360. We're going to finish solving this equation by subtracting 280 from both sides. We get x is equal to 80 degrees. Again, do not forget the degree symbol. All right, this last one, if you have not already, I would advise you please to pause the video and try this one on your own before watching how it is done. All right, first thing we're going to do here is we notice that some of these angle measures are not written in here because we only have 2 angle measures given and then the one that's missing. But we know that this little box right here tells us that that is a right angle, which is 90 degrees. So the first thing we're going to do is just fill in that degree. Now we know we're going to add 81 plus 90 plus 124 plus x equals 360. Let's combine some like terms. So we're going to add 81 plus 90, which is 171, plus 124, which gives us 295, plus x equals 360. Last step, and then we're done. Subtract 295 from each side. We get x is equal to 65 degrees. All right, again, if you have any questions, please write them on the side of your paper so that you remember to ask them in class. Also, if you need to go back through any parts of this video because you are still confused, you may just restart and review it again. All right, see you guys.